Hey everybody, and welcome back to Algebra 2 Online. So the plan for today is just do a few quick questions that are not necessarily anything new, but just kind of some weirder questions that are related to conic sections. And so let's just get into it. So this first one is just actually not as weird as some of the other ones that are coming up, but I just literally want to make sure that you can graph any conic section that I give you at this point. So, for graphs of these, I really want to make sure that you know where the center is for each one, and then basically use the A and the B values if it's like a ellipse or a hyperbola. And if it's a circle, right, the A and the B should be the same, and so you would just use it as a radius, right? When I look at this first one, let's do this one maybe in red. This graph, I can see the negative, so I know it's going to be a hyperbola, and it's a negative with the y term. So basically, it's one that is not going to go up and down, but instead it's going to go left and right. So let's just plot the center. So the center is at 3, -2, right? So 3, -2 is that right there. And then that basically for a hyperbola that's negative, what we really want is just the A measurement. The B one isn't really the more important one for getting like a point on the actual graph, because the graph does not go up and down, it goes left and right. So this 4 right here actually tells me that I need to go 2 units left and right. So from 3, I go over to 1, so right about there, and then from 3, I'm going to go to 5, right? And so I know that these are going to be like the turning points, the vertices for this hyperbola. But I do want you to use the B value for like the next part. So, we talked about I was going to write an equation of a line, but the slope of the asymptotes for the hyperbola is always B over A. I guess I should say plus or minus B over A. So this is where I would use the B value. So B is 5, right? Square root of 25 is 5. So what I do want to see on the graphs of these is you using that fact we know about the slope. So what you want to do is from the center, you're going to go like up 5, like over 2, up 5, basically up 5, and then left or right 2, and that'll give you another point on the asymptote, because the asymptote has to go through here, and then if you just go up and over, you'll get another point over here and here. So if we go up 5, that's 2, 4, 5, and then we're going to go over 2, so it's about right there, and then the other one would be about right there. And so this is one of the asymptotes, and then that is one of the other ones. It is good to show that it doesn't, you want to do dotted lines always for asymptotes because they're not really part of the graph. But this helps me sketch it because now I know, actually that was not drawn super well. I know that it just comes in and gets like really close to that. So something like that. And then likewise here, something like that. Okay. So that is basically what I'm looking for graphs of hyperbolas. They just need to be, roughly drawn in, I definitely want to see like this point. This point's an important one to know. And I want to see those asymptotes, and then showing something that gets close to these dotted lines. All right. This next one has a little bit definitely that we can simplify, because we've got already I can see a 2 and an 8, so we could divide by 2, right? But this can also be divided, so let's do this one maybe in blue. I would turn this into, first let's do the 4 divided by 2 there, and then we can go ahead and divide everything by 2. So if we do that, we would get this. And, you know, from here, you can see that this basically has to be a circle, right? The A and the B values in here are the same thing. Actually, written this way, this means the radius is 2, right? And so it's a circle centered at 0, 4. That's up here. And then for drawing a circle, I would really just want to see that you go out from that a radius of 2, kind of on the 4 corners, or they're not really corners, but you know, these 4 points to show that you know, those are the easy 4 points to do a radius of 2 on. And then you can just connect it with as best of a circle as you can. And then it's actually good to delete the center because it's really not part of the graph, right? You know, I didn't delete this center because it kind of had a dotted line that went through it. So that's kind of good there. It's, you know, it kind of becomes part of the dotted line, but here you should get rid of it. That's good. Okay. So that's just 2 kind of more straightforward questions. You're definitely going to want to be able to graph any conic section that I ever give you. All right. This is more of what I mean by kind of a weirder type of question. So we've got a very weird, this is an ellipse, right? Because 0.25 here is, well, it's positive, and this is positive. But 0.25 is not the same as 3,424 point blah, 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 blah. So this is an ellipse centered at 1/2 0 with some pretty weird A's and B's. Or maybe a weird B, but not such a weird A. But the question is, write down the equation of a circle, actually, which is just tangent to this conic section, and only appears in the first and fourth quadrants. So we can only have our circle like drawn in these 2 quadrants, okay? So this is kind of a question that's going to make you think a little bit. If I was you, I would definitely pause and take some time and try and do this question. I think this is a good one to think through about how you do it. I would actually use a graph to help me do it. So I would pause, think about it. Hopefully you've paused. I'm about to go through it and show you how I would do it. So I would start with the center of this conic section. So center, I said, is 1/2 0, right? So we've got 1/2 0 about right there. And we know that, you know, from this 0.25, A is the square root of 0.25, or just 1/2, right? And so the left and right measurement for this ellipse is actually, it's going to perfectly take me to the origin and then 1, 0. And so that is actually really all I need for the graph, because this B is like something very large, right? B is like a really, really big number because it's the square root of 3,424. But basically, I know that the ellipse comes through here, and then it just kind of goes down for a long time. And then, so it's like a super skinny one, right? I mean, I'm sure it goes way off the graph here, but I'm just trying to draw it like that. But I know it's a super skinny ellipse that does this, right? And again, really, the center is not here. So I need an equation of a circle that's tangent, so just touches this graph in one spot, and it stays in the first and fourth quadrants. So, you know, there's lots of circles that do this, but I think the easiest one, maybe just do one right here, right? So I could write the equation of this circle. So this is the tangent part, right? It's tangent, it's touching this ellipse in one spot. It's centered right here. It's got a radius of 1. And so if I wanted to write the equation of that, it would just be x minus 2, because shifted to the right 2, plus y squared, because there's no shift up or down. And then the radius is just 1, and that would do it. So this equation of a circle if you put this into Desmos and this into Desmos, it would give you some super tall, skinny ellipse. And then it would give you something that's just tangent to, this circle would just be tangent, touching it in one spot, and it would be in first and fourth quadrants. Kind of a weird question, but it's a good one to make you kind of think about the picture. All right, another weird question here. I just want to write down the equation of a hyperbola, ellipse, and a circle that share only 2 points, okay? So this is another one that I recommend you pause the video and really try to think about. There's lots of answers to this, but there's, I think, some easier answers to this too. So I recommend you pause the video right now and try and write down the equation of a hyperbola, ellipse, and a circle that share only 2 points. All right, I'm about to go through it now, so hopefully you paused. All right, so the way I would personally do this is, so let me just draw like a rough picture. So I'm going to draw a circle at the origin like that. I'm going to draw an ellipse that is like that, and then a hyperbola like this. Okay, so this is basically my plan of attack. I want a hyperbola, an ellipse, and a circle that only share these 2 points, right? So it basically, these three are all intersecting in just one spot right there, and then they're also intersecting right there. So those 2 dots are the 2 points, okay? And let's actually color code this. So I'm going to do my circle in blue. So I need just some circle that's centered like at the origin, which I can just do x squared plus y squared equals 1, unit circle, right? If I want my ellipse, let's do my ellipse maybe in, I don't know, we'll do it in like white. So we're going to do that. I want my ellipse to basically have the same center. So it's going to be x squared and a positive y squared. I'll make this equal 1. And I just need, if this is my center to go up, I definitely need the b value to be 1. So I'm not going to change that at all. But I need this a value, this measurement out, right? I need this to be just something. All right, so I need the y value, or the b value, to get me out just somewhere, further than 1, basically. Or I guess it could also be drawn, you could have an ellipse that's actually like that too. So you don't actually need one drawn the first way I had it, I guess, right? That would still be, that would still work for this problem. That would still be just touching in 2 spots. But we're just going to do this. So I'm just going to make some left-right a value that is bigger than 1. So we can do, here's a weird one, pi to the e. So square root of pi to the e, definitely bigger than 1. And so, that is some sort of an ellipse, okay? Now, for the last one, I just need this hyperbola to come in and, touch right there. And this is actually very, very similar to the circle. I can kind of start with this equation. And I want a vertical hyperbola, right? One that opens up and down. But the only thing I basically would have to change, this is still centered at the origin, still moves 1, b is 1. I just literally need this to be negative. If that is negative, then it will literally change my circle into this hyperbola, right? And so these 3 equations definitely do, if you graph them, you would get something like this, okay? All right, I'm just going to do one more question. This is just one more kind of trickier complete the square question. So these completing the square questions, when you have to factor out the numbers in front of the squared terms, are just a little bit tricky. So I think it's good to see one more of those. So this is definitely some sort of conic section. I just want to find the center of it and then graph it, okay? And basically what I'm going to do is I'm going to just group the x terms, and then I'm going to group the y terms, and kind of do the setup to the part where I would add a number for x and y to complete the square and get it in the form we know. So that would look like this. So all I've done here is I've taken a 9 out of these two terms, and then I've taken a 16 out of these two terms. And so these are kind of my purple x terms, and these are my yellow, let's say, y terms. And so this is now the completing the square step. So I need to put something in here that completes the square on these y terms, and put something in here that completes the square on these x terms. So this one would just be, so b is 2. So actually for both of these, b is 2. I just realized over here, negative 16 times negative 2 is definitely positive 32. So I need that to be a positive 2x right there. So both of these have positive 2's as their b value. So you just do 2 over 2, which is 1, and then you square it, you get 1. So they both just get 1's there. But this is the kind of reason these are a little trickier. A lot of students will forget what, if I put a 1 there, I have 9 times 1. So I need to put a 9 on this side. And then here I put a 1. So I need to do minus 16 times 1. So I needed to really add a negative 16 over there. So this is literally the same thing as this. I haven't changed anything. But what's nice, right, is the parentheses will be perfect squares. They will actually be the same kind of perfect square. The center is basically negative 1, negative 1. And then the numbers on the left will just add up to negative 144. And so now I can just go ahead, divide by negative 144, and like simplify what I got here. So definitely don't want to use decimals for this. Like, 9 divided by negative 144 is some just weird decimal, but you really just want to reduce the fractions so you know what like nice number is going to be on the bottom. And I am going to give you something like nice for these. I'm not going to try to give you like something weird, like this decimal here, like 1 over 3,424 point blah, 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 some weird number. So if you just do, the quick way to do this kind of stuff, to simplify this over, I actually take 144 divided by 9, see what that is. In this case, if you do 144 divided by 9, it is, negative 144 divided by 9 is negative 16. And that's the number that goes in there, right? And then you can just copy the top here, right? And then likewise, if you do negative 144 divided by negative 16, that would tell you what number is here, but we now know that has to basically be 9, right? Because we just saw 9 times this was this. So I'm just dividing by negative 144, but I'm just doing actually this divided by this to just see what has to go on the bottom here. It's just a way to tell me what nice number is down there. So this one, what did we just say was 9, right? So I get that. And I did ask for a graph of it, so let's go ahead and graph this thing. So it is a hyperbola, because I have a negative, which you might even be able to see right here, because you can tell you have a positive squared term and a negative squared term. So one of them is negative. Turns out that it's actually a left-right hyperbola. Basically, if you multiply through by the negatives, there's two x terms that end up becoming positive, really. And so there's a sign difference with it ends up being with the y's. So in this form, I can do everything with graphing it. The center is -1, -1, right? The slope of the asymptotes, again, is b over a, and b is 4, and a is 3. And so from the center, I'm just going to go up 4, up, so I went up 1, 2, 3, 4, and then I'm going to go over 3, so 1, 2, 3, so right about there. And then likewise, I can just go up, instead of going to the right, this time just go to the left 3. So 1, 2, 3, it's a little bit off, it's about right there. And those are my asymptotes for the graph. And then I just want to put the vertex, the two vertices in. So I know it's a left-right hyperbola because this is positive. So from here, just go 3 over to right there, and then 3 over 1, 2, 3 to here. And then you can just try as best as possible to draw something that stays gets close, I guess, to these asymptotes. So something kind of like that. So that is a rough sketch. That is all I'm looking for a graph of this hyperbola.